Here I introduce my self-built metal detector. This video is about my ideas and no building instruction. If you want to pick up something of this video, do it, but on your own risk. I think of an adjustment device for a finished coil. A shielding which has no restriction of the surging depth. A very compact vacuum thermoforming device, and much more. At first we start winding the coils. A 0.28 mm enameled wire I wrap around the coil device. The front end of the wire has a marking. Of course, the end must be labeled too. Here I want to show the effects of compression and deforming of the coil. The readings are millihenry. The shape of the coil also influences the inductance. This is not a disadvantage. In this way the coil could be fine-tuned. With the low inductance the corner of this D could be more rounded and the inductance increases. Conversely, of course, the sharpening of the corners reduces the value. I use for the reinforcement of the coil epoxy resin. Cyan glue is very hard and brittle. If bending the coil is necessary, the windings may break. This already happened to me. 3 layers of epoxy are made. This is for the insulation of the shield. Here I tried a shielding made of graphite. Aluminum-based shieldings always had a rise to the inductance. So it also affects the alternating magnetic field between the coils. My guess was that it dampens the sensitivity of the coil, but I am not completely sure. This shielding needs a good insulation against the coil. That's what the 3 layers of epoxy are here for. The graphite layer has the characteristics that it increases in its resistance per centimeter to 1.5 kilo ohm. To limit the resistance, I wrap in steep angle transverse 2 very thin wires. They must be firmly pressed onto the graphite layer. Therefore I wrap a tape tightly around it. For a winding in steep angle, its width is best 8 mm. Well, the inductance had not changed. And there is no connection between the coil and the shield. 0 ohms, 0 mega ohms. What a sunset outside my window. At this point a casing for the coils get necessary. You can buy it or build it yourself. Here I show how I made it. Most important is a frame for the vacuum. This is often built way too large. That is not really necessary. 2 plates, a strip of wood as an air gap and holes on the top, and I'm set. Oh, I forgot the vacuum cleaner connector. The necessary amount of extracted air fits easily through the holes on the top and through the space beneath. To build a model is much easier than it seems. Ordinary wood like spruce is cut with a jigsaw. It will be rough grinded and shaped with body filler. The effort of building your own coil housing pays off. because every further step is much easier. In addition, other parts can be produced too. In this way I built my armrest with the battery compartment. Between the two ears is always a fold. This I pressed flat with a block of wood. The thermoforming material ABS is pretty good. A plate of 2 mm thickness is glued to the wooden frame. And here I go. The vacuum cleaner is set to a maximum power and connected to the thermoforming unit. The oven will be controlled at 200 degrees Celsius. But stop here, safety first. Hands must be protected with heat-resistant safety gloves. Breathing must be protected with a good suction. The ABS sheet is placed in and observed. Heating the plate duration 4 to 5 minutes. For even heating the plate must be turned around sometimes. The preheating is finished when it feels like rubber. She starts to sag about 4 centimeters. Now follow quick steps. Vacuum cleaner on. Oven open. Press the plate onto the thermoforming device and quick the fold flatten. And now the same steps on the next object, the armrest. Here I show different results. This particular example was much too hot. The surface makes bubbles and wrinkles. The next both got a little too hot, but they are okay. From experience I know how unenjoying the interruption of a connection cable is. If the connection is glued in, you can throw away the whole coil. So I made a small junction box here. A piece of foam prevents from wobbling. And the lid has to be glued. The two coils TX and RX are fixed with epoxy glue and have an almost perfect so-called nulling. My adjusting device consists a slight bend of the straight piece of the RX coil. A plastic screw with a plastic nut does this. To this point a small box is built around. Here you see the shifting of the RX signal, the lower blue one. The yellow upper one is the TX as a reference. The best nulling point is slightly overcoupled, but later further details. Before pouring out, one must be absolutely sure that this oblong box and screw nut are dense, because here no resin should come into. The pouring out of the coil cover in the usual way, without such an adjusting device, became always a problem to me. I confirm that because I have never experienced that after pouring the so-called nulling has matched. Slow curing epoxy resin. The last step to the coil is pouring out the casing. To save some weight, I use so-called microballoons, tiny hollow glass spheres. There must be mixed so many microballoons into the resin until a thick mass is made. On this remnant you can see the characteristics. Hard, inelastic, lightweight. That's what I wanted. Here is shown once again the so-called nulling. The shifting through the null phase is visible. Rx is not at the absolute minimum, but very close, a little bit overcoupled. The adjusting screw gets sealed. The weight difference is not so impressive. It seems it's only 50 grams. But on the old one I milled out 120 grams. So adds up the difference to 170 grams. That's the whole electronics. On the top of the housing is the user manual. On the front end are all buttons, connectors and switches. There is socket 12 volt DC, on-off switch and pilot light. The volume control. The speaker. Jack for the headphones. A switch audio to LED signal. Controller for ground balance. Switch for ferrous metal discrimination. Regulator for discrimination of gold, silver, brass, bronze to aluminum. The two-tone switch. High tone for not discriminated metals and low tone for discriminated metals. Regulator for sensitivity, usually turned to the limit to the interference. The front end. Plug for the coil. A look inside. To get so flat, I used for the large electrolytic capacitors smaller one by 16 volt SMT shape. The large 8 volt regulator I swept off the flag and tipped him. The both integrated circuits LM308 were not easily to get shut. I replaced them with the OP07. And finally the two-tone board. My self-made PCB. Sometimes I build things twice. For troubleshooting, this makes things a lot easier. I guess Snowflake becomes vegetarian. What she feeds is called here cat's mint. Nevertheless, the PCB production is well known and often shown. The PCB for the TGSL is one-sided. The film is 3 times printed to be light tight. To fit the front and back, the film must be shaped into a pocket. The top contains the bridges and the component plan. Both sides of the PCB are positive photo-coated. That's my UV exposure unit. And his complete inner workings are out of a UV nail dryer for €15. The black case and the 8 cm distance between the lamps and the film produces less scattering and sharper contours. Developing, cleaning, etching. Therefore are these small plastic bowls. When developing and etching, I support some less advanced areas with a sponge. So far PCB production, so good safety. If with acid is worked, eyes, hands and respiration must be protected. Quick access to water is important. Make sure water is ready for emergency. The eyes have to be protected with protective goggles. The hands have to be protected with acid protection gloves. The workplace must be aired. Adjusting the TGSL is known. A piece of ferrite is swung across the coil and the ground balance slider rotated to the right until the signal falls silent. Iron is recognized. Then push the switch to the ferrite discrimination. Iron signals silence. Swing an empty tablet packing above the coil and turn the discrimination slider to the right until it gets quiet. The two-tone switch allows discriminated metals and not discriminated metals to hear in 2 tones. Last named but not shown is the sensitivity controller, the very right one. He will be turned so far to the left that the interferences start to disturb. And here I'm testing 2 coils. The one shielded with aluminum foil, the other is graphite plated. At first the aluminum shielded. A paperclip 15 centimeters. €1 just 25 centimeters. Screw 25 centimeters. A tiny pure gold coin 20 centimeters. An empty tablet package 55 centimeters. Aluminum foil 55 centimeters. Now the graphite shielded coil. Paperclip 15 centimeters. €1 over 35 centimeters. Screw 25 centimeters. Small pure gold coin 35 centimeters. Empty tablet package 70 centimeters. The piece of aluminum foil 70 centimeters. Now we are at the end. I hope you enjoyed it.